rated required amount of air to go across the coil, the switch will open. Why would we want this? That's one reason that the switch. So you need to know that flow affects more than one type of movement of air. So airflow and the filter could be considered one type of airflow restriction. It could be a restriction, which shouldn't happen if we have a maintenance program. It shouldn't happen. Airflow could also be restricted because of what? What?
Blockage of some sort, holding the line.
Motor. Isn't that really the airflow? If the motor in some of these is direct, then a direct motor shaft means it does what? It's directly connected to what? The motor.
Okay.
You have, let me see the capacity. What is that? Inside the furnace. What?
Fan?
The fan, we call it air distribution because it is, it's not up here anymore, it is the air that this motor here that's on this side is directly, like in a furnace, is direct coupled to the, to what some people wrongly call a squirrel cage. But we call it an air distribution wheel that has many little blades that cup air and push it up through the air handler of the furnace. So if this motor fails, do we have airflow?
Yeah.
That's another problem with airflow. If indeed this one is not, this is direct going to that shaft, but sometimes it is connected to a huge squirrel cage, a big one. And in that case, there would be a pulley and a belt. If the belt breaks, will we have airflow?
No.
So those are some of the ways that we could fail to have airflow. Motor failure, belt breaking, dirty filter, or blockage of a return. And that's in the ceiling, it's pretty good. I've seen some residents where they may have a filter on the side wall, maybe 4 feet up like this in the den, and they put a piece of furniture or a bookcase in front of that. Will that affect airflow?
Yep.
Will that affect cooling?
Yeah.
Because it needs to be 15, 18 inches off of the grill. That is a grill, that is a vent. What's the difference? That is a grill.
Return and push.
Return is a filter grill. Notice a grill. There is no adjustments to air. It's fixed. All of the vanes are pointed in one direction, and it's a return grill because the filter's in it. Sometimes it's a filter box, and it pulls the heat in air conditioning season through the grill to recondition it on the evaporator. A vent is what? Supply. A grill is return. A vent, and notice the angles. We're trying to get coverage. We have wedges of angles so that we can get different throws and pitches. Those are pitches. How is pitch to come out? You can buy the pitches that you want to get the coverage that you need. We're trying to cover this side and this side, and some coming out, and we do it in two, yes.
So they're not rated for a certain type of, like, you said you can buy the pitch that you want, is not per like type of room or how big the room would be?
Well, the good question is, how do we know what type to buy? These are 2x2 ceiling drop-ins. They're made to drop right in that space. You have to do anything. The duct is connected in the ceiling going back to the furnace air handler. It's a drop-in, those are easy. In a house that has a drywall ceiling, it has to be cut in. And so The vent, to answer your question, and the grill is sized according to the heating and cooling load, or BTU, of that particular furnace, based on the square foot of that room, based on,
Square foot of the house.
well, the square foot, you can do whole house or you can do room, and the BTUs are based on the structure's material is made of. Single pane, double pane, triple pane, shade, blinds,
Cause
all of that
one would be
affects.
more insulated than the other.
That is correct. And so what we're dealing with when we size BTUs is the transfer of heat. That's all we deal with. Transfer of heat. Heat is either going what? In or out. In the summertime, what wants to come in? We call it infiltration. What wants to come in? The outdoors. Outdoors say, I'm coming in. It's hot out here. I'm getting some of that air conditioning. So we're trying to make a barrier with the constructions that we make our windows out of, with the construction of the walls and the opaque surfaces and the roof insulation and the color of the roof and the thickness of the windows. And if a door is a solid core, if it's metal, if it's vinyl, if it's fire rated, all of these are impeding the transfer of heat. That's what we want to do. What is it like? Your clothes. You get up in the morning, whoop, wearing that t-shirt this morning. I need some more R value. I'm getting ready to put something else on. I'm gonna put a hoodie on and some other stuff, because your body heat does just like building heat. What does it do in the wintertime? It goes from a what to a what? Your body's warm. You know why you get cold?
Because you go outside.
And outside says, ooh, and your body says, I wanna go outside, it's cold. So it leaves your body, it leaves you cold. And it's going from a warmer to a cooler place. And then you go dress in a scuba diving uniform and put some other stuff on, it stays inside because you have insulated. It's like that in the animal world. Seals and polar bears are insulated with layers of fat. They don't get cold. They sleep in -40. Get up yarning. They don't have a problem, they're insulated. So the transfer of heat is reduced with the building materials that have the best R rating for heat transfer, not to move either from the inside out, which is heat loss in the winter, we lose it. Heat gain is in the summer because it wants to come in and join your air conditioner. So, to get back to your question about the vents, once we establish through Manual J a heat load in a particular room based on the building materials out of Manual J, then we can determine how much cubic feet of air we need and to return and supply for a given size room. Based on the CFMs for that room, then we decide or determine through Manual D for duct sizing, what size duct do we need? And the duct correlates with the size of the grill and the register. Because you have to, the return is gonna be bigger than supplies. Because air conditioning cools, because it does what?
It sucks.
It removes heat. So it's gonna remove the heat. I need a whole lot of room to remove heat. It's a sealed system. What does that mean? It has low tolerance to leakage. Every connection, I don't like to say every joint, every connection that the pipe is joined has to be sealed tightly, because it's a pressurized positive zone where you want to keep all the pressure inside. Some code requires that you put a type of mastic on the joint to seal it, that the system must be air tested to see if it has tolerable leakage anywhere.
What is mastic? You said
Mastic,
yeah.
M-A-S-T-I-C. Mastic can be a liquid paste solution that you can brush on each connection. So if we had a duct system, and that is where the air is connected, and say we have a section of pipe here, this is a section of pipe, well, mastic would have to go here, and mastic would have to go here. It looks like, for no other sake, it looks like grits. And you paint it on, and it takes a couple hours to dry, and it gets hard as rock. And it will seal that joint, and it will keep all air inside. So what's the best way to heat and cool? To keep all the conditioned air, whether it's heating or cooling, in the ductwork. So it makes it where? Through the room. That's how it works. The more leakage you have, the less tonnage you have in order to heat or cool a room, regardless to how good your math is. You may size the duct correctly, you may size the furnace and the air conditioning coil and the outdoor unit correctly based on the construction materials of that building. If you don't seal the duct, whatever's not going to the room is going somewhere else. And if it's not going to the room and it's going in the attic and it's going to the house, you're gonna have less tonnage, design tonnage that you need to cool and heat a space. Because in the summertime, all those leaks in the attic is heat goes where? Air goes where? Warmer to what? So all that 120 degree or more heat in that attic says, hey guys, I found a little leak in that duct. Let's go get cool. And it's gonna start lessening the cooling effect of that air condition, and then heating, it wants to go to a cool place. Hey, let's heat this 42 degree attic. And you in the house going, man, furnace running out of time, not quite the way, and you go up there. In reality, with all this, you know what flex duct is, guys? You know what flex duct is? What?
Flex duct.
Flex duct.
Coil that.
It's like a slinky. Y'all too young. You don't know what a slinky is?
Like
Yeah,
a sliver.
yeah, you old. Yeah, you old. You know what it is. It's a little wire coil, and not really a wire coil, and it has silver. Most of the time, it has a silver reflective, like aluminum on the outside, but on the inside, it has a R factor, which tells you R8, R11, and it'll tell you what the barrier for retention of heat transfer is. The more expensive, the thicker, the more it costs, the more it resists heat transfer. Now, sometimes flex duct, if not installed properly at this fitting, because it's flex, so flex duct is kind of like this.
Isn't that the same material that's behind your dryer? Or similar to it?
Just like that, except it has insulation in it and it's thicker.
Okay.
And so you should on this end have what we call a collar. And it's called a starter collar. And a starter collar is so that you can take this flex duct. I might bring some here. I got some in my garage. I'm trying to get it.
And you can put it up there.
And you can fit it on, and then you take a wire strap with a wire gun, goes quick, quick, quick. Some people try to pull it. I got a strap gun. Put it on there, go squeeze, 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 and it tightens it. I pop screws in it. So that the wire strap won't come loose or break. It's gonna hold the lip of this flex duct on there. Then I clip the tail off, then I wrap it with tape, and then I mastic it. Nothing coming through. I'm mastic.
That's it.
Yes, sir. I just need to speak with you when I get a chance. Give me a second.
About what?
No, quiz star.
The Quiz Star?
Yes, sir.
What about it?
I never got my,
For third or fourth?
third.
So the flex is the connecting. It's sized from mostly now for houses. It used to be odd sizes. Now it's 6, 8, 10, 12, 14, 16, 18, 20, 22. It's in those sizes. There's not mid sizes anymore. We used to have 7, 7.5.
Why they cut out the mid-size?
And we did it in metal because it really, according to most air engineers, that it doesn't really make that big of a difference, even though it was perfect math. and nobody wants to pay for it. I came up in they called them 10 knockers. We worked with sheet metal. They called us 10 knockers. So all that duct, it wasn't flex. We cut it, we manufactured it, and we crimped it on the edge, made it fit, wrapped it, and connected, and screwed it in. And so when I first got started, long time ago, we had drills, but not that kind of drill with all those hex head fittings. So we had to take a punch and tap, and you pump a little hole in it, and take a screw and screw it in there. That punch was real sharp too, because they go through that metal like that. And so we was happy when we saw hex heads come up, like, oh, this is it now, baby, this is it. And so sheet metal costs more, is stronger, and commercial is used a lot. Residential, it was cheaper, it was faster, and made it more affordable for the customer and for the builder. And it's such a quick install. If it's done properly, there's nothing wrong with it, but unfortunately, people train people quickly to do this. You might do it 5 jobs with a tech, now you the duct man, pulling this duct, and it cannot go like an anaconda. It must be pulled tight. We usually take 2 people and hold on to it and shake the wire impression on it, and then connect it, keep it tight, and we strap it to the beams in the attic every 4 feet with flex strapping, which is a minimum of about 1 3/4 inches of cloth, so it doesn't eat into the flex and cut a hole in it. Some people put wire on it. You have to use the proper material. And so why are we stretching? Remember the flows. Why are we stretching? Sheet metal was smooth inside, right? That air just went through it. Had a good time. Hey, I'm through here. It was NASCAR air. It was getting. Then when you put flex, anything that's on the inside, it looks like this. It's coil. So you want to stretch the coils out so they look like one coil. And for those of you that's too young to remember a slinky, it was like that. That's why I say it's slinky. And you could leave it there to be one step. And old time kids were very amused by it, because you could take it like this and go, whoop, and it would drop to the floor. Then you could make it come back and you could take it to your hand like that. So children of that day and age was really, they thought it was fun. They played with it all day. They would walk down the steps too. Like you put it close to it, because of momentum. So the reason that we have to stretch flex duct is because of turbulence. And when we started briefly talking about Manual J, it's some in your book. I usually don't go this far, but since you asked, I always address what you ask. It's based on airflow, it's based on feet per minute, how fast air moves. CFM, how much volume of air moves, and how we can have as least restriction to the flow of air to a space. You didn't know all of this took place designing the system. You thought you just went up there, threw a unit outside, threw some line sets on it, set a furnace and a coil, psh, psh, get my money. But it's more than that. Because a lot of times, the reason I'm going into this is because a lot of times the issues that we have with equipment, whether commercial or, especially commercial or residential, is encompassing one or more of the flows. Airflow is critical. Non-restrictive airflow. As we said, metal does not restrict unless anytime you go away from straight, you're gonna have a problem with airflow. You want all your runs to be as straight and as short as you can to here. Straight coming this way off of a plenum and pop, maybe 5 feet or 4 feet dropping down here. Tight, tight. So you don't have restriction, because restriction, as you'll find out later if you have my class, it causes static pressure. Static pressure is the enemy to airflow. You want the flow of air to come the shortest route. And what does that mean? So for instance, if you were on a furnace and you had a vent pipe right here, you really want it to go straight up to the roof. Isn't that the quickest, most clearest route? However, what if I was right here and it's going up to the roof right there? So sometimes you have to change the route, and you might have to put a 90, and then when you use 190, you usually have to use 2, because you gotta get back to where you were. And then you're going up straight, and you're going out the roof, and you're gonna be up there. So anytime we do this and do that, fittings, those are called fittings, cause restriction. Not always a real bad restriction, but it has to be accountable for, because its restriction is against direct flow where we want the air to be. So if we say we wanted 380 CFMs out that vent, then we have to make sure all flow is coming that way. I'm not gonna stay in this a long time because we have a whole class for this. But I wanted you to know at the beginning that I think it'll help you to know that conditioned air is more than a machine, because we can't get the air if we don't have flow or ductwork to flow it through. It has to flow through something. A lot of times the issue we have on a system, like I said, is directly with flow. You know, it could be the filter, that's simple. It could be a broken belt, that's simple. It could be a motor that has failed, that's simple. It could be a capacitor. All of those affect airflow. But we're gonna learn in refrigeration, there's some other items that affect refrigerant flow. And that's just as bad. And then we have condensate or water flow, which is the result of a cold coil of 40 degrees pulling return air up through the evaporator, removing heat and humidity or moisture at the same time. That's what a condensate. So we have to have a certain attention given to condensate, because condensate can cause flooding problems if it's not, if the system is not installed correctly over a ceiling in an attic and you don't have a secondary drain pan, it will flood and take out the ceiling. Thousands of dollars on you and you for not putting it there. But if it was put in with a permit, it just wouldn't pass inspection until you did it. But if you booted it in and didn't do it, and the ceiling is 30 feet high, some of these houses and the repair could be $8,000, because they're not gonna let you put a little hook up there like you learned on YouTube how to fix it. They're gonna say, we're calling a drywall ceiling company called Buckhead Drywall Ceiling Company, and they're gonna charge $8,000. They're gonna say, we're gonna take the whole room down. We can't match it.
If they're gonna do that.
And it's on you. It's on you. That's why you better have that business insurance now. Better have that insurance. Or you're gonna have to pay for it out of your pocket. So here are some ideas that we're having about, and the airflow as well is as big a part as servicing as these mechanical parts, because it is a component of the system. And many of them, especially nowadays, when we start using zoning boards. What is a zoning board? That's in there as well. What is a zoning board? What's a zone, first of all? An area. So you can zone a system different ways. We're talking residential. It's been in commercial for years. So we can zone by having two systems. That's pretty common. One system upstairs, one system downstairs. So that's two zones. And the zones are operating to create comfort air in two different areas with two different machines. You can also zone with a zone board, say if I had a 2-ton and a 3-ton, I may put in a 4.5 ton that can carry the load of upstairs and downstairs if it were zoned. In this case, zoning would be dampers. You know what a damper is? I know what a damper on my day is, but that's a different damper. So, if I had this duct like this, and I wanted to control where it went, it's very common to have, and then I'm gonna change what we're talking about. Some of y'all going to sleep.
Restrict flow, certain areas,
Huh?
restricts the flow to certain areas.
It could.
Control the flow.
This would be called a bullhead T. That's what it's called. As opposed to a straight T. That's a straight T. So this could be 10. Okay, I don't care. This could be 10 inches, right? This could be 8 and an 8. Because as the math go, I can run 2 8s off of 10 instead of taking up all that room on this one box over the furnace. I have 8 here, 8 here, an 8 here, and an 8 here. Well, I can put a 10 here and run 2 8s. I can put a 10 here and run 2 8s. So it takes up less room. Now, each of those areas where we go off from could be a zone. A zone board can carry 1 to 4 zones, most of them in residential. So if we wanted to, normally it's half a house or half a house on one level, or it could be upstairs and downstairs, which is very common. So upstairs and downstairs could be that, just for example only, upstairs and downstairs could be like this. Down, up. One system. So this system here would have this system here would have a damper blade right here. The damper blade inside that duct goes like this. So you say it shut off? How does it operate then? How does it shut off? Everything, remember, we're talking about control. So you have to say, well, you could just say, well, how do we control it? As a tech, how do we control it? Even if you never saw it, how do we control it? How?
Switch.
Switch?
Programming.
Programming?
Airflow.
Airflow.
It's by air.
Part of what you say is true with how one part works, but the other part is, remember when we first talked about controls, we said that controls work primarily 3 ways.
Water.
That's 4
Temperature.
flow. I'm gonna get it in you after a while, you'll get it. What?
Temperature, pressure.
Pressure
Oh, pressure.
and time.
Time.
So you say, okay, how do we control it? It has to be one of those ways, doesn't it? But if we're dealing with airflow, and when an area is satisfied,
Temperature.
temperature. Because here's how it works. We have a zone board here. 1, 2, 3, 4, and then it has a stat connection here, which also has a condenser connection that goes outside to the condenser. So, we also have sensors, because you told me it was temperature. Sensor here, sensor 2 here, that's gonna be stroking this one. Then we have, this one might be upstairs, so we have a stat upstairs. This one is downstairs, so we have a stat. What are these things stand? What are these things? Dang. You might not wanna know what they're made out of. So a stat downstairs, and you decide as a customer which stat. Anybody here live in one of them kind of houses?
Yeah.
Do you?
Yeah.
You got two stats, don't you? Which one controls the unit? Upstairs or downstairs?
The one in the kitchen.
Huh?
The one in the kitchen, the downstairs.
Downstairs. It ain't in the kitchen, I hope.
Well, it is in mine.
It's in your kitchen?
It was like the foyer area kind of.
Cause if it's in the kitchen, that's ugly. Don't put a thermostat in the kitchen, but
Yeah, it's like-
depends on all these new houses have this open format.
Yeah.
Everything's open. I walk right here, I'm in the family room, I'm right here in the kitchen, I walk over here, I'm in the dining room, ain't no walls. So the stat needs to be over there, kinda like in your little family room, away from the heat of the kitchen. So, but if it is, it is. It should be near the return. It should be near the return as well. I don't know if you have a return down, you should. I don't know, you might check that. Okay, so mine is controlled downstairs. Some people like them controlled upstairs. If you're an upstairs person, they want it controlled upstairs. So the upstairs is cycling that unit on and off, cycling on and off. It's the boss. It's communicating with the board first. Now, if I get satisfied, here's the issue, right? So they're so much better than they used to be. The issue is if I get satisfied, meaning I am what? What? Satisfied means I'm at set point. So if I'm satisfied in that set point, then upstairs, that blade is wide open and it's starting to close. But it's gonna close to a minimum. We normally set ours a minimum of 15%. So some air goes by. Why? Why?
Keep it room temperature.
Why?
Control.
You don't want that to close all the way because then that's just cuts off
What?
the air to the other places.
Okay. Without knowing, that's good. What happens, we said we're dealing with static pressure, airflow. What did we say? What happens to a balloon when you keep blowing it up? So if both sections satisfied and there wasn't another part to this furnace, so there are mixed air sensors in here that sense that air temperature in that duct as well. Because it would keep blowing air against that flex duct until something came loose. It would keep blowing. Because it's resistance. I can't go anywhere. And I used to say, what if both areas get satisfied? What happens then? Well, actually, none of them gonna get satisfied at the same time, really, at certain times of the year. But I said, if it does, what happens? And so it used to be, which I see now, on the return side, from the supply to the return, there is a bypass duct. Let me see if this guy 1 minute. And tell me what you think that is.
Overflow.
Yeah, it's like overflow.
Y'all got your homework? Yeah, now y'all see?
Ooh.
You need your stuff too? You gotta eliminate, you got his shit say perfect.
Best, I was.
Like a book.
Stand up real quick.
That's what it does. Stand up, yeah. Stand up. Shit. I was fighting.
Up in the plenum, in between these ducts and going right back to the supply. And what does that do for us? It relieves the pressure. So therefore it's no pressure pushing down on the duct is free spinning. It's going around the supply, but it's in the supply plenum, and it's going to the return, and it has a sensor on it that when that sensor is satisfied, because eventually it is, the fan will shut off until the next call for cooling. But both stats can call for temperature. And so it's not very difficult to hook up, because on the furnace it tells us where the sensors go. So if a sensor here, there's a sensor here, the sensor 1 and sensor 2 will connect to the board. There is a drive motor, tiny little drive motor. It's not any bigger than this. It's 24 volts connected to a shaft to that blade. So when the motor turns, the blade turns, and it's actually going like this because it's on the side, and it's going like this.
So the motor can control it.
By temperature. The motor is the load that controls the movement. We're back there again. The motor controls the load, and if it has a load, how many volts?
24.
24 volts off of that board. So you don't even have to see it, but once what I'm trying to drill in you is this load, whether it's 24 or load, whether it is driven from motors or compressors or attached to relays or attached to primary L1 and L2, T1 and T2 to a relay or a contactor. It's still main purpose of a contactor or a relay is to close a load, a switch, so that something moves. That's it. And so all we do is look and say, so that's why I'm gonna keep pushing sequence of operation. Even in your heat lab, sequence, have you did that yet?
No,
Cooling?
no.
Cause you're just first. You're just first. I'm just teaching you up. Always go up. Cause it's more fun to attach it to something you're going to, but how you deal with it now. It makes more sense to me. Plus, we're talking about it on the board, those electrical boards. And it makes sense to know what they're doing, that even though we make these lights come on that says fan, and it goes to a relay, true enough, but the light that's a fan does have a load, doesn't it? But it doesn't have the load as a motor, but it's standing in place for a load, And the more you get this in your head about load, switch, pressure, temperature, and timing, you 50% there. So what we did with the zone board is to say, what kind of device? For one thing, if I look at that device and I see sensors on it, then I'm saying I'm measuring something. If I look at the sensor right here and it's there, it's measuring airflow. If I'm outside on a unit and it's a sensor, it could be a pressure switch on a regular air conditioner because it's mounted in line. What that means is if I have two lines, a suction line and another smaller one, which is liquid or discharge line, the sensors in reality are mounted in line because they measure pressure. They're in line mounted. So they're measuring, if it's on the liquid side, it's measuring what? High pressure. If it's on the suction side, which means low, it's measuring low pressure. So anytime we have a sensor that's measuring, we said a sensor can do two main things, and what are those?
Measure the high pressure and the low pressure.
Which is safety, or it can be safety or operation. Because the thermostat is a sensor, when it's satisfied or meets set point, it does what?
Cycles off.
Cycles off. So the thermostat is temperature. It's either temperature or it's either pressure. And timing. And you could look at a cell switch as a air pressure switch. Because if I don't have the right amount of pressure of air in CFMs, this switch is gonna open. And it opens and tells us, hey, it doesn't tell us anything. It opens and we are reminded when that switch opens that there is an airflow problem. The service connect would be, where could it be? Filter, motor, belt, 98% of the time. Motor might not be running because you have a bad contactor. Might have, not a bad, nothing's bad on the machine, a failed contactor or a failed broken wire or a failed capacitor. But all of these are connected to airflow if they connect to a motor. If, in this case, if there's no air in a particular part of a zone, and it's operating the machine and it works upstairs, then it's telling us with the little bit that you know that what's going on. We have two dampers.
Okay, and say it again.
If it's cooling upstairs and it's zero flow downstairs on a zone board system, what is that telling us if the thermostat is set for both dampers to be open?
Something's
One of the dampers are closed.
One of the dampers is closed. And that's obvious by airflow.
Maybe the motor on one damper.
Could be the motor. Could be, well, the blockage would be if it's
The
closed.
sensor? Maybe the sensor's
It could be the sensor. You looked at my notes.
off? No, I'm looking, you just said about what we know.
I don't have no. So, it could be the sensor, because the sensor is measuring. Y'all gonna get this after a while. The sensor measures what? If it's an airflow or a temperature, it's measuring whatever that particular sensor component is manufactured and designed for, that's what it measures. So if the components, which is again, now you're gonna see why sequence of operation is one of the elements that derives the correct response on service. Because if I have a damper mode system, zone system, and first you must know that two zones operate two different areas, and they operate to two different areas by a zone board, and the zone board communicates with sensors, and the sensors could be air sensors for temperature and mixed air duct, zone delivery air duct, that closed switches on a board that allows a motor to be, zone motor to be energized, causes it to go into motion and to open and close dampers to a particular area. That's how it works. And if both of them get closed and it's still airflow, then we have a bypass, which goes, as we said, from the return supply to the return, and then lets that air go just like this. And there's a sensor in there. And when that temperature drops enough for this fan to be de-energized, it stops the flow, especially if both dampers are nearly closed. And you can set them. Some also have what we call in some systems the barometric. Barometric, here I'm talking about the water. Barometric meter says they're doing weather. Our business sound like weather all the time. Barometric is pressure. Barometric pressure. You know what's cool about it? A lot of controls in our business, I just wish I had been smart enough to do it. They're so simple. So barometric damper would be in here from the supply to the return right here. It's a bypass, and it has a damper here, and it has a weight on it, and it's weighed. And if the pressure builds up too high in it, it'll open and let that air out to reduce the pressure. So it's gonna be right here, and it has a blade, and it'll go pop when the pressure gets too high, takes it off the blades of the zone dampers and takes it off the pressure of the duct. Pop, and it'll open, then it'll close. Pop, and it'll open and close until that air ceases to, and it's automatic. Has no wires. It's a pressure operating, somewhat like, but not quite. It's just pressure on that damper that works something like how any pressure control opens when it exceeds the pressure rating that is designed or set for, because you can set these pressures of static pressure. You can set it, and it'll pop at that pressure because that's the design of it. Okay. Do you recall any of this that we talked about as far as duct systems? We'll come back to it later chapters, but I want you to kind of associate this above the ceiling and below the ceiling, the activity and the components that are connected to a furnace above the ceiling and below the ceiling, and that you have an idea of what a total system is. We make it cool from evaporator to condenser. We connect the line set with the 4 major components of the refrigeration cycle. And then when the fan is cycled on, and it has to go somewhere. So it's connected to a ductwork, and the ductwork is connected to the areas. And you must supply and return, because air condition cools, not because it blows cold air, but because it removes heat. So therefore, the return duct is gonna be bigger because I need to remove more heat than I need to supply to those areas. And by designing, by Manual J and Manual D, we derive the size of system we need for heating and cooling. Also, by those BTUs per each space, we derive the size of the ductwork, and then we can go to Manual S and determine the type of equipment that we need to supply the air and the heating needs and the cooling needs. Yes?
Makes sense. Like, so all those manuals, are they located in one area?
What?
You said you go to Manual J, Manual.
There are 3 different books.
Okay.
Manual J is basically area, state, all the states in the United States and the major cities. Also, all the materials for windows, for doors, for roofs, for raft areas, for crawl spaces, for whole basements, for half basements, for tinted windows, for any construction that a house could be designed and made of is in this manual. And all we do is look up numbers, construction numbers, as well as building materials and such as windows and doors. We get a number, which is a U value, and then for air conditioning, we have to get a CTD, which is a cooling temperature difference. We get a heating temperature difference for heating calculations. All of this is easy. It's so easy. And then for cooling, we have to be concerned about directions, north, south, east, west, and also we have to convert a CLT to a CLTD, which sounds like it's so complicated, doesn't it? It is so easy. That's what I teach. It is so easy. Some people know that it's so easy. All you're doing is like that person chart. This equals this, that's the number. That equals this, that's the number. And I'll give you 4 formulas. And they're not formulas for math. They're formulas like HTM, that's heat temperature multiplier. HTD, heat temperature difference, and all of this. And those are the 5 you're gonna use, and then say multiply HTM by HL, which is heat load, and that will give you BTUs. I give you a little card to follow those. It's so easy. You don't feel so So that's gonna really help you, and I believe that you should know the full system. And then it might bring about a better interest when we start talking about these controls, because they're all gonna be operated by pressure, temperature, or sequence of time and location of the component. Is it indoors, outdoors, air handler, condenser, on the wall? Where is the component located, and how does it affect the system? Electrical issues are probably 80% of all problems. And it's so easy. You just have to make a determination, is it low voltage or line voltage that's the problem? And that could be a little challenge at first, because if I have an issue with line voltage, an issue with low voltage. I don't have no line voltage if it's closing relays and contactors. There is no line voltage, but it's there. So like we said, you have to know where to test the line voltage. If I'm outdoors on that unit and L1 and L2 say 240, do I have a line voltage problem?
No.
But I'm not gonna get it from T1 and T2 because the relay has to close. If the relay doesn't close, what kind of problem do I have? I have a low voltage problem. Now, what kind of low voltage depends on what my stat is set for. But I said the quickest way to determine if we have low voltage is to do what? Turn it to fan. We have low voltage because the fan relay closed and the fan ran. We have low voltage. So inside, we're probably good, but always check the filter. Always check the filter, because in air condition, a dirty filter will cause the evaporator to turn into a solid block of ice. And then the refrigerant will not boil off or vaporize, and it will go to the compressor as a liquid and stab him in the heart and kill him. That's what he'll do.
Dramatic.
So we hope that the low pressure controls this before it gets there. Because low temperature is low pressure, and low pressure should open the switch, the safety switch. If we're in heating and it's running and running, which I ran across this weekend, you don't have enough airflow, the heat's gonna build up in the heat exchanger, it's gonna get hotter and hotter, and the system's gonna cycle off by the limit. It's gonna cycle off the limit so much, that means it's off, and when it cools off, it's gonna come back on. Yeah, it's off, and when it cools off, it's gonna come back on. It's gonna do it so much, it's gonna burn up the limit. And now it's never gonna light. Take a break. What do you need, Chris? You never had one? What's your last name?
Is it 15 or?
You started, you just got here.
Oh, you,
How long did it break?
yesterday, man.
Every day?
No.
Hey, my day,
Yeah, okay.
Don't do it on the
They got my shit, right?
No, yeah, real talk.
Yeah, smart, you got turn 14, man. What's up, bro?
I'm coming.
No, that's 14 from
I'm
last
about to do that.
14.
But I'm coming.
Unit 14.
Yeah.
Yeah, some people already turned it in. Yeah, you can turn it. Yeah, it's right gonna be 30, I guess it's 30 minutes. Oh,
So basically, we just choose,
Booty.
company and we just see, like, I don't even know what to do, I'm just playing. It was like two, they were messing with.
What's up, Tim?
Component doesn't have to have Mr. Resistor. If it was a contactor, you would have to say, the contactor could be, the contactor could be like that, right?
That's the relay or contact, right?
It could be that, but this is just taking the power from L1 to T1 to neutral. That in itself is no, you still have to have
Something to close.
a load. So we'll just call the load a coil, and we know it could be a motor. You were right as far as the contactor, but the contactor is talking about, remember we said some components have dual responsibility. So the contactor's dual responsibility is, it can transfer when closed, it can transfer, well, we could have put a switch here too, and left that here. A contactor, when it closes, has to have something down here as well. But how does the contactor close?
When you turn your stat on, then I think it's in.
Say it again? A 24 volt?
He said, how does the contactor close?
24 volt has to be applied.
It has to have
When you plug it
24
on,
volts.
the thermostat, right?
So the L1 and L2, the thermostat, you're asking good questions. The thermostat is a switch. What kind of switch? Temperature switch. All a thermostat can do is open and close switches. So where does the 24 volts come from?
Thermostat.
Transformer. And there we go again, the transformer has two power sources. What? Primary, whatever we want it, and then the secondary is gonna be the 24 volts in this case. So the 24 volts is across the coil of a contactor, but the line voltage is going from L1 to T1. And when the line voltage, this is the coil that's on the contactor, T1 and T2 is going to have another load in order for something to do work. We only want the work to be done when the contactor closes. The contactor closes from the 24 volts, you told me, by a stat. A stat is just a switch. It's just a switch. And in this case, it's not just any switch that's open and closed, but how it opens and closes is by temperature. So it's a temperature switch that opens and closes at a particular range of temperature, whatever set point is. When it closes, in this case, 24 volts goes to this coil. When that coil closes, it goes down to a load from T1 to N in this case. And something runs. So by that, we want to be able to understand the series. That is a good question as well, because the series would be, that's the 24 volts. The series is in between the contactor coil and the thermostat. So the series would be high pressure, low pressure, for instance, right? Say 2 pressure switches. Why? Because that's the series. These are in series with the 24 volts to the contactor, meaning if pressure is too high, the switch opens. If pressure is too low, the switch opens. When the switch opens, this wire coming from the stat represents what color? It does represent R or red, but not in itself, because at the thermostat, we have what? What else? And sometimes C. So if you were putting, because you're at this contactor, saying that it's on the outdoor unit, if that is so, then when we go into cooling and lower the temperature, the switch closes at the thermostat by R, Y, and G. G is what?
It's fun.
Y is what?
Cooling.
But cooling how? It's really not cooling. Cooling is what it does when the switch closes and the Y circuit proves to be closed. So when we go into air conditioning mode or cooling mode, the thermostat actually closes switches to G, Y, and R. R becomes Y when it starts to go out to the condenser. That's why. That is why. That's why you can jump R and yellow. It becomes Y, and so we can break it. It's a power leg. It's a power leg. If we jump these two, they're the same thing, aren't they? So as it goes outside to the outdoor unit, then the series circuit that you talked about in this case is going to be the series circuit in the control circuit of Y. There are safeties, it's safeties. It is also a cycling. That's kind of weird, isn't it?
Yeah.
Because it's a safety control if one of the high pressure or low pressure between Y and AC going to the 24-volt transformer senses a failure. Low pressure, low temp, low pressure, low refrigerant, high pressure, dirty condenser, high pressure, fan outdoors, failed, there's no airflow, high pressure, high temperature, open, and the high pressure switch opens. When the purpose of the high switch or the low pressure switch opening is to open the contactor. If we open the contactor, compressed outdoor unit is off. So we're not operating it at an unsafe condition, in an unsafe environment for the machine. Ask questions, it might be a lot. Okay, that's the safety and the series. The operating part of it is when the thermostat is at set point, meaning what? Set point is what?
Reach this desired.
Desired limit or desired condition that we want. So we set it for all laughs and giggles, 70, and we're at 70. We want the unit to do what?
Shut off.
We want it to cycle off or shut off, right? So what does that look like inside of a thermostat? Open, open, that's it. It opens, there's on temperature this time, on operating temperature, no power to the contactor, contactor opens. So it can be safety or operation. Operation means we met set point, nothing has failed in the series circuit. It's perfect. But we have reached our satisfaction at the thermostat, and now we cycle off. So it's operating and safety. So if it's not running, one thing we do is we walk inside the houses, and you say, well, you might be a technician, say, let me walk around the side. Oh, it's not running. Well, I can kind of feel the unit a little bit to see if it was running. I can look at the suction line and see if it's a little sweat on it, and I can go inside the house and go, woof. It's probably off because it's satisfied. It's not off because it's not running. So is it overrunning? Is it beyond set point that we're at 60 and we wanted to be at 78? That could be a different type of sensor problem, but that's control for operation, and the series circuit is control for safety. So series here is also safety, not to ruin the machine. Controls protect, controls operate. They do them both. Does that make sense?
Mm-hmm.
It controls any question. If it doesn't make sense to you, then I'll talk to you. If it doesn't make sense to anybody, then you say what doesn't make sense to you, because everybody needs to move forward. I want this class to move forward as a group. I want you to look in the fourth semester and see everybody sitting next to you.
That's right.
Stay here. Stay as a group. Learn as a group. Graduate as a group. Get higher as a group. At different places.
You go throw us a quarter? You gonna turn us up or not?
But if everybody in this class is
Yeah.
still here,
You might go turn us up.
if everybody
Pizza,
in the class is still here,
cheese, pizza.
sure. If everybody in this class is still there.
I got you right now. Hey, I got the
No,
proof
and
right there.
mine is like
Minus a couple.
yeah, don't do it like that. Some of them ain't gonna make it.
All of them ain't gonna be here.
Well, you better help them make it.
No, we all gotta
They
make
make
it.
their brain for
We
it.
all gotta make it, bro.
Exactly.
They may
Hey, who we
not
got
know
in
how
here?
to ask for help.
Who we got
Aw,
up there?
man, come on.
Oh, yeah, listen.
Listen
to me.
man.
No, I'm
You
not.
trying to short us
I'm
out
showing
the
you how it works.
business?
Look at this. If you work
Who
at
all
a company,
been? BT,
in a business,
Waleed?
everything is working together. Some people are stronger.
Let's see who gonna
Some
make it.
people receive
We all gonna
information
make
quicker.
That's like a group picture.
Some people
I'm gonna
We need to
can
group
learn
picture.
from
After
their
class.
peers
Yeah.
different than they learn from
No, we
me.
need to wear that shirt.
Some
Oh, the
students
IT?
can take
Yeah.
criticism from their peers
Just in the days
better
when
than
maybe
they can take
parents
from me.
didn't.
Let's do
They
it.
talk their language. Come on, man.
So, you just
our responsibility.
You better get off that
Like,
something, cause you know that's what's wrong with you staring at the wall, you ain't even learning. You better
That's me.
you better get on that comprehend, so you can comprehend, clear the mind, clear the mind.
Sam.
It's so easy to learn, clear the mind.
Agree.
I ain't talking about no generation stuff, 'cause that's all generation. But clear your mind, and you might be surprised how smart you are. And you might be embarrassed of what you did to not be so smart. You will be smart as you cannot be. And then guess what? So when you get a certain age, you gotta make a decision how you're gonna proceed in life. Because that's what makes people climb. And they say, boy, he's so smart. He ain't on puffing stuff, that's why. That why
Isn't
he
it
gonna be your
eight?
boss and
31,
y'all be at
eight?
the same
You
time.
get 8
That's
for
how that
31?
works. And I'm gonna say that the whole time you're here, because at the
I'm
end
not,
of the
I'm not sure
road,
about
I got
that.
D,
my
You got
job
D?
is to get
which
you
is A
hired.
and C.
And I can't get you hired if you can't hook up to the machine in your.
Yeah, that might be right.
OL is open lead.
And I get 3 or 4 of them every 4 semesters.
It's not
With
No.
great jobs, and they
OL?
be smart too.
Is it?
So this one has them.
open lead, yeah.
Okay, yes. See, well, you better take another job and come back to this offer later. Cause if you blow this offer now, they're never gonna take you again. So you don't get on this apartments and make the decision in your life how you wanna live. You gotta make a decision how you wanna live. That's a lot of money.
You can do the ones I know.
That's a lot of money. 150, 200 a month, 200 a week doing that. That's too much, I'm too cheap. I'm too cheap to be on. Can't do it. I can't do it. It's too much money. I can't do it.
Hey, Mr. Tech guy, did you buy the Apple Vision? The Apple Pro?
I
Or you
don't
gonna
do
buy it?
anything Apple right now. I did it one time
Mm.
because you mean for like video or anything?
Oh, they just came out with some,
I got the glasses.
About $4 or $5.
it's not even glasses, it's like a shield like this.
Is it 3D?
You could use your phone and you could like,
Oh yeah, I saw that like on TV. It's like
About $5,000.
no,
You know,
3,000.
never buy first or second generation,
Never did. I never bought that.
right? Because the video cameras used to be like this, the VHSs, and now they like this.
Bro, what you got for 31?
So technology hasn't. The first people pay for the design,
Yeah.
and the next people pay for the consumers as it picks up. It's only going to be a certain amount. But are we straight on the series in parallel? So the other thing I didn't cover is this series, lady. Serial killers. Look at this. This is parallel, just like in lab. The lights are low. That's a low.
Crazy, bro.
That's a load. If this load is a pressure switch and it's visualized as this light
I'll buy it.
and this is high pressure, if this switch opens, what happens? No light? Cereal? What happens?
You said at the low number what?
Under load number 1, if the switch opens, what happens to load number 2?
And on the same circuit?
They're on the same parallel, they're both getting L1 and L2.
Nothing happens.
I feel like
Hold on,
if it's
parallel
parallel,
circuit.
then it don't have nothing happen on number
Say
two,
what the
but
question
number
was
one
again.
part is.
There you go. But if the same thing happened here, all go out. That's safety. Parallel could be that the fan is running outside, but the compressor's not running.
Okay.
It could be one component running, but the other one not for a given
But they're
reason.
still good. Anything in series is out of there. If it's
It's
not.
out.
Alright.
Series is holding
I was
hands.
confused.
It's out. Somebody, if you in a circle and one person lets their hand go, it's no longer a circle. Series is if you hanging off of the north face and 10 people are hanging and number 2 drops off, everybody below them is down except the one holding.
Okay, and 20 said HR, we got HR 2 times, we got it on the evaporator coil and we have it on the heater. So I'm just gonna go with the heater on 20.
All relay?
Yeah, relay.
On what now?
On 20, on our diagram, it says that which one is gonna energize for H and R. And there's H and R,
But they ain't
sometimes
gonna
we
move
have it on the evaporator fan and you have it on the heater, so I'm just gonna go off of the HR on the heat. 'Cause I know
That they both have a relay. A relay for the evaporator could be the fan. A relay for the heat could be electrical heater. And one runs in cooling and one runs in heating. The relay, a heater has a relay, a evaporator fan has a relay, but both of them have a fan that the same fan for heating is the same fan for cooling. Except the gas could be on the gas furnace and the fan runs through a relay. And then, because those relays are gonna be on boards like this. And then the fan, the relay for a gas valve could be on a different relay. If they're talking fan relay for the heaters and a fan relay for the fan itself. Because heaters can be on relays too, it's not one here. But if it's electric, I don't think it says whether it's electric heat or not. Let's see. Okay, so that's a parallel. Okay, all right. You're gonna bring it back with you then. I already did, I'm done. You done? Give it up. You'll get another chance. Thank you, sir. So you have evaporator fan relay, and then you have a heater relay. And so that heater would have to be, the heater would have to be electric heater. And on electric heat, whenever the heating elements are energized, the fan must run on electric heat. So what else do you have?
My question, that's it. He has one.
Is there a limit to how many loads can be on the motor?
The only thing that limits loads is the design of the system. When we design an electrical system, we determine by the loads that are rated in amps on each component, whether it's in a motor circuit, and then we design the wiring and the breaker for that load not to exceed. For example, a furnace is 15 amps. The transformer is normally 40 VA, volt amps, on a residential normal furnace. And so the load is the heat that develops on a particular line conduit that is showing up at a contact. And why it does it is, if it's higher than a rated value of a particular component motor, then something is failing in that system of a bore. It could be dirty inside, windings could be failing, it could be the shaft, the stator is starting to stiffen and fail, and it's dragging. And when a motor drags, it picks up amperage. In that case, the amperage would be converted back into a safety problem that would trip that breaker that can go back to the motor. So you could amp the motor and say, what is the amperage? Well, the motor said 13, and it's saying 46. Well, you're in lock rotor position, and that motor is failing because it's either dragging, or bearings are gone, or something is going wrong with that motor. It's hanging up, maybe the squirrel cage is caught up and dragging. Something's putting drag on that particular motor that would cause amperage to rise and put us in safety. And sometimes these motors have internal overloads that will open to protect the motor, and certainly when we talk about compressors, we'll get to that. Internal overloads. Some overloads can be external, but internal overloads that protect the equipment's windings from burning out for a given reason. Any other questions? You ready? Well, I thank you, sir. I thank you. Let me see. Mr. Smart. OQE. 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 Okay. I'm trying. Okay. So this circuit is 240, that is true. CC energized. What happens when CC is energized?